This is another chemistry sample paper for 10th standard. And our section A is going to be of 40 marks, and we are having the first question being the MCQ question. Let us look at our first one. Molten lead bromide is used. Acidified water and copper sulfate solution using copper electrodes were electrolyzed in three separate experiments 1, 2 and 3 respectively, in which statements the electrode products is correct. They are saying where it is correct. Now experiment number 1 and 2, which means for lead bromide and acidified water, uh, metals were formed at anode. Now at anode for this Br2 will be formed with lead bromide, and acidified water O2 will be formed. So this will be Br2 and here it will be O2. So metals are formed over here is not the correct one. Metals were formed at the cathode in experiment. At cathode in Br2 is correct, and in 3 copper sulfate will have Cu deposited. So this is the correct one. So this is your B correct. Gases were given out at cathode. No. Gases will be the anions. Anions will never be at the cathode. Gases were given off at the cathode. Never. Gases will be always at the anode. So the first part is B. We come to the second one. Second one was a little bit out of syllabus because of this term. This is to be used by pharmacists. So which is not for ore dressing is this one. Magnetic separation is for ore dressing for magnetic and non-magnetic. This is for the heavier particles, and pulverization is powdering, correct? So this one will be the odd one out. We come to the third one. Let us move very fast. As you move down the group, in the periodic table, the elements become more metallic in nature. When they become down the group, why do they become more metallic? Because the atomic radius is going to increase. So the pull on the electron from that force or the pull is going to be less. So electron will be lost more readily and cations will be formed more readily. So more metallic. So they are telling you which is the explanation. Electrons are more easily gained. No. Electrons are more easily lost is correct because of increasing atomic radius is correct. What is the C part saying? Elements are heavier due to atomic radius increasing. No, they are going to be lighter because atomic radius increases, volume becomes more. Volume becomes more, density becomes less. Elements are heavier due to the mass number increasing down the group, uh, but the most apt is going to be this one. So we come to the next one. Diagram shows the structure of ethene. So C double bond C, so it is an alkyne. Which of the following compounds are similar chemical properties to that of ethene? So if you are able to look at the double bond here, you have to look for double bond. So there is a double bond here. There is single bond, so no, single bond, so single bond, so no. So which is the correct one? A is the correct one. Why? Because it is the alkene. Let us move very fast and understand our questions. Gas cylinder of the portable heater contains 13 kgs of butane. How many butane molecules are there in the gas cylinder? Avogadro's number has been given this way, and RMM is 58. Now, if it is 58, it will have Avogadro's number. Let us say it is N. So, if it is 13, then it's going to be how much? So, that X is going to be equal to 13 into 6.022 into 10 to the power 23 divided by 58. Now, unfortunately, 13 is not a multiple over here, or 58 is not a multiple of 13. So we had to do the long division after multiplying this. So 13 twos 26 carry 2, 13 twos 26, 28 carry 2, then 13 sixes 78. That 78 is to be divided by 58, and this is 10 to the power 23 here.
Excuse me, ma'am.
Huh.
Ma'am, the 13 kg, we have to convert it into grams, ma'am.
13 kg, oh yeah, correct. This is 13 kg, so you'll multiply this by 1000. So multiply by 1000. Correct, no? Yeah. So now it will be 58 ones 58. It was a little irritating question. 20 are remaining. Then we will take this 2 and we'll put the decimal point here. This will go here how many times? 5 3 is 15. So 3 8 is 24, 2, 3 5 is 15, and 2 17. We will have 12 minus 4 is 8, and here 2. Then we'll take this 8. This will go how many times? This is 1.3 here. 1.3, so 5 times will be, yeah, so 1.35 is correct. So you don't need to go ahead with these, all right? So 1.35, this is correct. Now let us check with this. This is 10 to the power, how much is it? 26. Can you see that? 23 and 3. Can you see that? So A is the correct option. This was a little time consuming question. That's it. Choose the correct alternative from here. Okay. Here dilute sulfuric acid with carbonate liberates CO2 and gives the salt is correct. This is correct. And this is dilute acid property is correct. This and this gives you this is HCl lab preparation. This is not the it's telling you it's the non-volatile nature. So this is non-volatile nature. So this is not the oxidizing property. KCl plus this conc, this is non-volatile is correct because it is going to displace the more volatile acid. Correct? This is more volatile acid. Your temperature will be less than 200. So this is correct, non-volatile. And this is oxidizing nature because sulfur is oxidized to this. So this is correct. So which ones are correct? M, O and P. Where is M, O, P? This one. The seventh one, when ammonia is passed over heated copper oxide, it changes to reddish brown copper is correct. You remember the reaction 2NH3 plus 3CuO. On heating gives 3Cu plus 3H2O plus N2 up arrow. Now remember, similar question would have been asked with another compound which is PbO, which is amphoteric in nature. So remember, CuO will be basic in nature, this will be amphoteric in nature, and with NH3 our reaction would be 2NH3 plus 3PbO. On heating gives 3Pb plus 3H2O plus N2 up arrow. Okay, now here what is happening? CuO is becoming Cu by removal of oxygen. So it is reduction that is happening. So this becomes the reducing agent. So when this is the correct thing because we are getting reddish brown copper from this black CuO. Reason, this is oxidized by ammonia. Ammonia, if it is the reducing agent, it cannot oxidize. So A is true, but R is false. Option C. electroplating spoon with silver is shown below. Which statement is correct? The metal electrode should be connected to the negative metal electrode. Uh, Spoon should be at the positive and metal electrode should be at the negative is correct because it's going to be active electrode. The spoon should be connected to cathode, which is correct. At the cathode, silver ions gain electron. At the cathode, Ag1 plus will migrate and they will gain electron and they will get deposited. Correct? So this also is correct. Silver argentocyanide is uh, used as the electrolyte. Silver argentocyanide.
Not used silver
It will be
argentocyanide.
molten silver
Yes,
ion.
ma'am. Yes, ma'am.
Yeah. So uh, this is not correct. So it will be 1, 2, 3. 1, 2, 3. Okay.
Ma'am, why is 1 not given in the option, ma'am? Because it's given only 2 and 3 only.
1 is here now.
Ma'am, you said option D was correct. And
No, which one is correct? Oh yeah, 2 and 3. No? Where is 1, 2 and 3? What is the first one? What did I do? The metal electrode would be connected. Metal means Ag, right? Ag should be connected to anode is correct, no? No,
yes,
sorry. Negative
cathode.
is cathode. Sorry, mistake.
Yes, ma'am.
Okay, so metal should be at the anode. Mistake. Okay, metal should be where? At the anode, so 1 is not. My mistake, sorry. Now here, select the correct option with respect to electro refining is in copper. Now this is your Wx, Y and Z. The whole thing is not fitting properly. So let us see Wx, Y, Z. Wx, Y and Z. They are telling you select the correct option. Thin pure strips of copper and anode is slabs of impure copper. Electro refining of copper, to begin with, before we read this also, you will have to have cathode as the thin sheet of pure copper, it will have to be, and anode will have to be impure copper, and it will have to be a thick slab. So this is correct. Slabs of impure at the cathode, no, we will need pure. So this is wrong and this also is wrong. So X is wrong. Thin strips of pure copper become thicker, yes. And here anode impure gradually diminishes in mass is correct.
Yes.
Ha. Then impure slabs gradually get finished. No, there is no impure slab here. And thin strips of pure copper become thicker. That is not at the anode. Impure thick slab becomes thinner. So this one also is wrong. Understood? So X and Y is the correct option.
W and Y. Option A.
Which one it is?
W and Y.
W and Y, no? This and this, right?
Yes, ma'am.
So it is option
A.
A. Then bromine water, reddish brown. It is shaken with these. Which one will become decolorized? Means this will be the test for unsaturation, means double bond or triple bond, which means it will be either alkene or alkyne. So this one is CnH2n plus 3. Correct or no? 6 and 3, no? So this is no formula. What is this? CnH2n plus 2. Correct? 9 2 is 18 and 220. So this means it is alkane. We want alkene and alkyne. So not this. What is this? CnH3n. No. 2n 2n plus 4, no? This also is not an option. What is this? This is CnH2n. Now this is the formula for alkene. Alkyne will be CnH2n
Yes,
minus 2. So D is the correct option. Okay, let us come to 11. Compound X reacts with Kong sulfuric acid to give black spongy mass, means carbon has been given. With Kong sulfuric acid, it must have got dehydrated. So this is going to be something from uh, which water molecules have come out. Understood? Because Kong sulfuric acid is uh, dehydrating agent. So this will be either sugar or glucose. Correct or no? Understanding?
Yes, ma'am.
Now, if it is sugar or glucose, it will be a covalent compound. See what they are telling you, molecules and all that they are talking. Which means we are coming to ionic or covalent compound. है ना? So let us look at the options also same time. X contains only molecules is correct because it will be a covalent compound like glucose and sugar. X will not allow electric current to pass through. Correct or no? Because it is non-conductor of electricity, covalent compound. It
Yes.
contains ions as well as molecules. No, it will have only molecules. Will it be a strong electrolyte? Never. It will be a non-electrolyte. So what is the correct option?
B.
B is the correct option. One
A
minute.
and B are
A
correct.
and B. A and B. है ना? A and B is the correct option. So that is this. Yeah, sorry, I got confused between this B instead of this B. So option was B is correct. Now this diagram shows you have to find the correct product. Now can you see this is ammonia gas with oxygen? Is it catalytic oxidation or normal oxidation? It is normal oxidation, correct? The catalytic oxidation, the diagram is you will have something like this and platinum and ammonia is passed over that, correct or no? And then it will be passed through this where NO becomes NO2, correct or no? So this is your normal oxidation. So 4NH3, you have to remember this with 3O2 is going to give you 2N2 plus 6H2O. Correct? So what are the products here? Nitrogen water vapor is the correct one. Not this, not this, not this. Okay? So you have to know all these reactions, pit pat you have to know. So if you are able to see that, you will see that you have to intensify your preparation. Oxidation of ammonia, remember what I told you the trick, that both oxidations will have 4NH3 plus some O2 and it will give us something plus 6H2O. For both of these, we are going to get 4NH3, remember. So 12H, that means 6H2O will be for both of them. Understanding? But if it is normal oxidation, then you get N2, so it becomes 2N2. But if it is catalytic oxidation, then you will get 4NO. Now once you have this, you can balance the oxygen. If it is 2N2, then 6O, so I'll have 3O2. But if it is catalytic oxidation, then we have to write platinum here also, and it will be 5O2.
5O2.
So platinum and 800, 700 to 800 degrees C. So and plus 22,400 is the heat, exothermic reaction. So you have to know these reactions by heart. It is lots to remember, but remember you have to intensify your self-study just now. What are they telling you over here? Which of the following statements are correct? So boron and this thing. So you will need the visible representation of your periodic table. So period 1 is hydrogen and helium here. Then I told you little Betty's boyfriend caught 9 orange fish never. So helium will be here in period 1. Period 2 is here. Period 3, they are telling you boron and lithium. Now boron is here, lithium is here. As you go here, the non-metallic increases. So can boron be more metallic? It will be more non-metallic. So keep this in front of you. Then magnesium. Magnesium means I'm coming to period 3. So naughty magazines are read by all sick people, says Clinton in Argentina. Keep this in front of you. Mg is here and silicon is here. So if I come this way, Mg is going to be more metallic, is correct. Okay, then carbon is less metallic than beryllium. Carbon is here and beryllium is here. Carbon, I'm going this side, means it is more non-metallic. So less non-metallic is wrong. Sodium is less metallic than aluminium.
Less metallic. So
one minute, what did I say? Oh, less metallic. Sorry. Less metallic means more non-metallic. So this is correct. And sodium is less metallic than aluminium. Sodium is here. Aluminium is here. So this side, if we go, it will be more metallic. If I go this side, it will be more non-metallic. So sodium is more metallic. They are saying less metallic. So correct option is 2 and 3. Okay, so remember this is how you have to do this, like in 5 seconds you can write like this, or 10 seconds, and then you think it out, and you can actually come to the speed of 1 mark per minute. The hydroxide which is soluble in excess of NaOH is going to be, now hydroxides, remember, are bases. Okay, oxides and hydroxides, what are they? They are the bases. Now a base which is soluble in excess of NaOH will be amphoteric. So you will have to take either zinc oxide, hydroxide, or aluminium, or Pb. Where is it? Can you see this? Okay, so that is how we have to come to thinking of this solution. 15th one. Very dilute nitric acid reacts with magnesium and manganese at room temperature. So remember, I have told you MnM, that is Mn and Mg, they will react with cold 1% dilute HNO3. Why? Because HNO3 is oxidizing agent. When it is 1% dilute, the oxidizing property is very less. So it will form the salt. This will also form the salt, and it will liberate H2. Otherwise, H2 will get oxidized to H2O. We will not get hydrogen. So what is the reason? Oxidizing action is reduced due to dilution. So this is true, and this also is true. So both of them are true. Which one it is? Both are true, and R is the correct explanation. Yes. Understanding, right? So we finish with the first question. Let us quickly move to this electrolysis of molten lead bromide. Now, lead bromide, you must know in your mind PbBr2 dissociates into Pb2 plus and 2Br1 minus. Pb will go to the cathode because it's a cation, and Br will move to the anode because it's an anion. Why is crucible made of silica? So silica, there are number one. What is the first one? It is
Not reactive.
non-reactive. This is the first one.
Which stands high temperature.
Because lead bromide has the melting point of how much? 380 degrees. So which stands high temperature. We don't want a crucible that will melt at 380. And next one, it is non-conductor of electricity. Okay, so these are the three reasons. In your textbook, I have told you to number them as 1, 2, 3. Okay, why should molten lead bromide be used? Don't say that because it conducts electricity. You have to say that what is the first reason that you should be writing? That PbBr2 is
It contains free iron.
No, first is ionic compound, because metal and non-metal, no, it does not contain free ions because it is a solid, correct? Ionic compound, and ions not free where? Not free in which state? Solid state. But ions become free in which state? In molten, which is the other word we use for molten? Or fused. Okay, molten state, and can conduct electricity. Okay, so this much has to be mentioned. Understood? Then we come to why is graphite preferred over the other electrodes? For this, remember that Br2 is corrosive. So you have to say that graphite inert in nature, correct? And one more thing you'll have to add is not affected by what?
Corrosive bromine
vapors.
Yeah, correct. Affected by, y'all are writing, or only I am writing? Y'all are writing corrosive bromine vapors. Y'all are writing because your finger muscles also need training up. Your observations at cathode and anode. So you have to write cathode and you have to write anode and then write the observations. Pb is going to get deposited. What is the color of Pb?
Silvery gray. Silvery gray deposits of
silvery gray deposit of what?
Lead metal.
Lead metal, and I would prefer even atoms, because remember they become neutral at cathode. Anode, bromine. So this will be easy. What is it?
Reddish brown bromine vapors.
Reddish brown bromine vapors. Okay, let us come to the next one. Next one is pretty simple. This is, what is your brass? Brass will be this 3. So A will be 3. B will be oxy acid, means has oxygen in it. Hydrochloric acid doesn't have oxygen, sulfuric acid has. So this will be 5. C will be bronze, will be CuZnSn. Where is it? Here. And remember, They will also ask you regarding bronze, which are the two major components. The major components is copper and this Sn. All right. So this is C is 1. Then D, hydrazine means,
Hydrobromic acid.
so that is this. And ammonium nitrate is explosive in nature.
Explosive in nature.
So this was, most of you got that right. So that is correct. Complete the following. Ammonia reacts with excess chlorine. Now remember the two reactions, NH3 plus 3Cl2, where ammonia is in excess, and NH3 plus 3Cl2. You have to know both the reactions by heart. If it is ammonia in excess, it is 8NH3, give you 6NH4Cl, please write, and plus N2 is the gas liberated. And if it is chlorine in excess, it will be, this will give you NCl3 plus 3HCl. Okay, and then the observations are extremely important. For the first one, NH4Cl means dense white fumes of ammonium chloride, and for the second one, NCl3 means yellow oily explosive liquid. Which one? Nitrogen trichloride. Okay, we come to excess chlorine. So it will be ammonium chloride. No, excess chlorine means nitrogen trichloride. Okay, the mass of 56 grams of carbon monoxide at STP. Now carbon monoxide GMM of CO is going to be 12 plus 16, which means it is 28, right? Yeah, so if I have 28 grams of it, it's going to have no, 1 minute, centimeter cubes. 22,400 centimeter cubes will have 28 grams as the mass, correct? So if it is 56 centimeter cube, then it will be how much? So your X will be equal to 58, correct, no? This gives you 28 grams, this gives you, yeah, so 58, what did I write here? 58, 56 into 28 upon 224,000. 56 ones and 56 4,000 times.
Yes, ma'am.
4 goes 1,000 times and 7 times. So you have 0.20. Oh, sorry, there are 2 zeros. What did I write? How did I write 3 zeros here? Yeah, so 0.07. Okay, this one. The next, higher homologue in ethanoic acid. Now after eth comes prop, no? 2 carbon is S, 3 carbon is prop, so it will be propanoic acid. Where is propanoic acid? This one. Okay, so homologue means the next one in that homologous series. The electrolytic reduction of alumina, what is used to lower the fusion temperature? Cryolite. Now actually this cryolite as well as fluorspar is there, but which one I have given you, right? Cryolite, no?
Yes, ma'am.
Cryolite. Yeah. So in fact both of them are this thing. So if you look at the, can you just take out that textbook? I want you to just bring to your notice something. What page it is on, quickly?
page 139.
Metallurgy, na?
138.
138 actually, yeah. It's the left hand page. Now can you see over there in point number 3, fused cryolite and fluorspar are added, and the first bullet says that addition of cryolite and fluorspar lowers the fusion temperature. Second one says cryolite and fluorspar also enhances the mobility. And the third bullet says addition of cryolite enhances the conductivity. So fluorspar has the two functions, which is for lowering the fusion point and also for increasing the conductivity. And cryolite has all three functions. So if they ask you fluorspar, the first two functions, and if it's cryolite, then all three functions. Now, although fluorspar, if you have written, it is correct, but my experience is that the examiners have given cryolite as the correct answer for this. They should have mentioned cryolite and fluorspar together as the option actually. If an element has to have low ionization energy. Now, low ionization energy means it is low IP. That means to remove the electron, the energy required is less, which means it is going to lose electron easily. This you must understand by this low IP. Okay, if it is losing electron easily, it is going to form cation easily, so it will be a metal, so it will be more metallic. Some of you did have a problem with this. Name the following. Let's go fast to name the following. Gas produced when conc HCl is made to react with MnO2. Now this your reaction you must remember by heart. It is going to be 4HCl conc, and that on heating gives you MnCl2.
MnCl2.
And
Yes.
remember, this HCl is going to remove H because this is an oxidizing agent. Okay, so it is going to give you H2O and plus Cl2.
Cl2.
Understanding. So remember this MnO2 reaction, you have MnO2, PbO2, Pb3O4, KMnO4 and K2Cr2O7. These are the 5 oxidizing agents. MnO2 oxidizes HCl, making it Cl2 by removing hydrogen. Removing hydrogen and adding oxygen means oxidation. So HCl has got oxidized. Okay, so what are they asking you? Just the products. The products formed when conc HCl acid is made to this thing. The gas produced is going to be chlorine. Okay, so this is your A answer. You can even be asked what is the oxidized product. The oxidized product, HCl becomes Cl2, so Cl2 is the oxidized product. Which is the oxidizing agent? MnO2 is the manganese dioxide is the oxidizing agent. So did you understand the kind of questions that can come? Is it making sense to you? Process of heating the concentrated ore at high temperature in presence of air means roasting. Okay, the key word was in presence of air. In absence of air will make it calcination. Then roasting and calcination, remember there are 3 points of differences. You have to learn those also by heart. Okay, tendency attract shared pair of electron towards itself is which one?
Electronegativity.
Very good. Then minerals from the metals which are extracted commercially at comparatively lower cost and minimum effort are what? Minerals. What are they? They are the ores, no?
Yes, ma'am.
Ores.
Metallurgy.
Metallurgy is the branch of chemistry which deals with extraction of metals. They are saying minerals. So the minerals from where I can extract metals will be the ore, no?
Yes.
I take the ore of the metal and then from there I extract the metal, right?
Yes, ma'am.
Huh. So gas, yeah, sometimes it can be confusing, huh? You read it twice and think, pause, and then you write the answer. Gas produced when mixture of sal ammoniac. Sal ammoniac is,
Ammonia.
NH4Cl. Okay, and slaked lime is what?
CaOH
CaOH twice. The gas produced will be from NH4OH. NH4OH means unstable.
Unstable
It gives you H2O
ammonia.
and
NH3.
are you with me?
That's not.
Okay. The structure for neopentane. Just take a little break as I drink water. Look away from screen. Now remember, pentane has uh, three structures. One is N-pentane, isopentane, and neopentane. So if I have 1, 2, 3, 4, 5, isopentane means like this, and neopentane means like this. Understanding? Yes? So it will be CH3 everywhere, and this will be your neopentane. You have to write H everywhere. Okay? Propanol. What is prop? 3 carbons. Can you see that N here? That means all single bond. And what does al mean? Aldehyde, so double bond O, single bond H. And everywhere here this will be Chhatri Chattu. Okay? Are you able to write as fast or faster than me? Are you able to write fast or no?
Yes, ma'am.
IUPAC. IUPAC. What is this? This is oic acid, right? So 1, 2,
Yes,
3, 4 means what is it? Bute.
Butanoic acid.
Huh. Single bond means N and then butanoic acid.
Ma'am, do we write?
No, you don't write 1 butanoic. 1, 2, 3. This is prop. Okay. And here double bond means it is in. Now some of you will say prop 1 in, but if you look at it, if you say prop 1 in, prop 2 in means it will be like this. If it is like this, then I'll have to count from here, no? Correct or no? So it is propene only, not prop 1 in. Understood? Propene, whether the double bond is here or here, the naming will be the same. If it is here, I count from here. If the double bond is here, I count from this side. Understanding? What is this? This is simple. 1, 1, 2, 2, tetra bromo ethane. Okay. Now question number 3.
Ma'am, shouldn't it be dibromoethane?
How many bromo are there? Tetra, no?
Ma'am, but that won't come in IUPAC.
IUPAC name only they asked. Supposing you say dibromo, then it will be like this.
1122 dibromo.
Yeah, this is your 1, 2, dibromoethane. There are 4. How can you not say tetra?
1122 tetra bromo.
Bromo, yeah, tetra bromo ethane is correct. Yeah? Still confusion?
Yes.
Still confusion. What is the name of this?
1, 2 dibromoethane.
And you said this also is the same. This is also the same here.
Ma'am, won't it be then 1, 1, 2, 2 dibromoethane?
How dibromo? There are 1, 2, 3, 4 bromines are there, no? See, when you say 1, 1, 2, 2, you're giving the position of one bromine, then another bromine, then another bromine, and then another bromine. You are mentioning there are 4. Then how can you say dibromo here?
Yes, ma'am. Thank you, ma'am.
Understood or what?
Yes, ma'am.
You are thinking that for 2 carbons only the bromines are there. That's why you're saying di. No. One,
Yes, ma'am.
monobromo, dibromo, tribromo means how many bromines are there, not how many carbons.
Yes, ma'am. Thank you, ma'am.
Understood?
Yes, ma'am.
Okay. Now confusion gone.
Yes, ma'am. Thank you, ma'am.
Welcome. Now question number 3. So sodium hydroxide undergoes complete dissociation in water and forms a positive ion. So which complete dissociation forms a positive ion and a negative ion. So it is going to be Na1 plus and OH1 minus. Draw the electron dot structure of the negative ion, that means hydroxyl ion, and name the negative ion. So remember, this hydroxide has come because of water becoming, see, basically it is H dot OH, which is going to give you OH1 minus. Understanding? So you have to show the structure of water. The oxygen is here. This is this is your H. This is another H. Correct? And this is going to lose what is it going to lose? This is going to lose one protium here. So this hydrogen is allowed to leave. So you have a O here, okay. This is like, this is how, and plus it will be like this. Understanding?
Yes, ma'am.
Ma'am, there should be one more lone pair, right?
Where is one more lone pair? 1, 2, 3, 4, 5, 6. Yeah, this one here. Yeah, oxygen has 6. So 1, 2, 3, 4, 5, 6. Correct. So then it will have 1, 2, 3, 4, 5, 6, and these two from the hydrogen. Understood the formation? And what is the
Yes,
ion
ma'am.
here? This is hydroxyl ion. I don't know, y'all did so much of variety of hydroxyl ion. Preeti performed brown ring experiment in the laboratory. What is the chemical name of brown ring?
Nitrosoferrocyanide.
Very good.
Hydrocephalus.
And what is the formula? FeSO4.NO. Correct? B. When Preeti disturbed the test tube, the brown ring decomposed. Why did it happen? So brown ring is unstable is the first answer. Okay, it is unstable, and on disturbing or shaking, what happens? The heat dissipated breaks down the brown ring, and the whole solution becomes brown. So remember, we have sulfuric acid also. So that is dissipated in this, but on shaking, that heat is going to uh, break this brown ring. Why does compound sulfuric acid settle down? It is heavier
It's
than
heavier.
FeSO4. This was common sense. This is where many of you had a problem. Now, this one. Empirical formula of this compound, I do not know, this was your Na 37.6%. Then we had silicon 23. Do you have the calculations of this ready so that
Yes,
I
ma'am.
don't waste, because we have already solved this? I'm doing the corrections of these. Make sure that you have this percentage. Then you have the atomic weight. The atomic weights are here: 23, silicon is 28, oxygen is 16, and then you have relative number of atoms. Please mention this, okay? Don't just write these numbers, also draw the columns. So it will be 37.6 upon 23. This will be 23.1 upon 28 and 39.3 upon 16. Do you have the numbers ready here?
Yes, ma'am.
Huh.
1.632,
1.63,
Then,
0.82,
0.82,
and this will be, just keep it like this now, and
2.4,
2.4. So the simple ratio, you will write 1.6 upon 0.8. Okay, then 0.8 upon 0.8. You have to remember that these numbers are to be given as a simple whole number ratio. So do not write this 1.63 divided by 0.8. Then you will not get 2. You understood what is happening? Some of you write up to like 2-3 decimal places and then get totally confused. It has to be simple whole number ratio. So can you see, this is a simple ratio. I don't have to take this because this is less than 5. So in my calculations I just take this. Then it becomes very easy. They are saying empirical formula will be Na2SiO3. Okay, now let us come to the next question. uh, Observe the reactions and answer the following questions. Okay, now here maximum confusion has happened. Could you just write this question so that I can help you in understanding? Just write it down, tell me when you're done.
yes, ma'am. Done.
Okay, now
Done.
remember here they are saying that compound plus HNO3 is going to give you something plus H2O. Okay, and the compound plus zinc is going to give you something plus H2. All right, now if I have salt and water here and there is salt and hydrogen here, so this compound with HNO3, salt and water, I know this is acid, so this must be a base. Agreed? Agreed?
Yes, ma'am.
Okay, so this is going to give me salt and water, but remember that this plus zinc, it is a base, right? So base plus zinc, now zinc means it reminds me of its amphoteric nature. Understood? My normal thinking will be zinc plus dilute acid will give me salt and H2, correct? Supposing it was HCl. Okay, then I would have said ZnCl2 and H2, correct or no? But
Yes.
I cannot say HNO3 plus HCl gives me salt and water, no? Understood? So this will be either my NaOH or it will be KOH, because if it is reacting with zinc, this will give me Na2ZnO2 or K2ZnO2. Are you understanding?
Yes, ma'am.
Okay, so please write this. These are the thinking steps over there. Now, what is my A answer? Identify Z. Z will be, I'll write sodium hydroxide. Now, if I have a choice between sodium or potassium hydroxide, I choose sodium because sodium compounds are more easily available. Okay. If you write potassium hydroxide, you will still get your mark. Write the reaction taking place between identified Z and nitric acid. So NaOH plus HNO3, this is going to be neutralization reaction, and that will be NaNO3 plus H2O. Agreed? And name the compound Y. Where is the compound Y? This one, no? No, this one. This is Y. So your name the compound Y is going to be sodium
zincate.
So this was maximum confusion in many of you. Now let us just discuss this. In the first step of contact process means for sulfuric acid, right? Iron pyrites are roasted. Write the equation of the same iron pyrite. What is the FeS2 plus O2, and on heating it gives you which oxide you will get?
Fe2O3.
Very good. And plus which oxide of sulfur? SO2. Correct. And what did I tell you to mention over here? This is 2Fe, so I'll write here. So it will give me how many S's? No. I had told you this is O2.
11.
No. That is okay. But if you've forgotten that 11, then it is here 4. So this is oxygen, which is even number. This oxygen is even, this is odd. So you have to make it even. Understood? This is the first step. Then this doesn't become 2, it becomes 4Fe. Then S becomes how much? 8. And then you will get 11O2. Okay, 60 grams of iron pyrite roasted. Calculate the volume of oxygen, the weight of ferric oxide, weight of sulfur dioxide. How many of you get confused for something like this? Is there anyone who will get confused for this?
Yes, ma'am.
Okay.
Yes.
So if you get confused, what are they telling you? The reaction, have you written first? Tell me. Have you written the reaction? Not yet, no?
Yes, ma'am.
You finished writing the reaction?
Yes, ma'am.
Okay. So I'm just rewriting it. It is what? 4
Fe.
uh,
FeS2
4FeS2 plus 11.
plus 11O2
That will
gives
give us
2Fe.
2
2Fe2O3
plus
8SO2.
Okay. Now 60 grams of iron pyrite means this is 60 gram. Understanding? And they are saying volume of O2, that means this volume equal to question mark. Okay. Then they are telling you weight of the ferric oxide formed. So mass of this equal to how much? And weight of sulfuric acid, so that is M equal to how much of sulfur dioxide. Okay. Now they have given you RMM of FeS2 is 120. So this becomes 4 into 120. Put bracket and write gram. Okay. Molar mass of Fe2O3. So this they have given 2 into 160. One molecule is 160. So 2 molecules will be 2 into 160. And molar mass of SO2 is 32 plus 32 means 64. So 8 molecules means 8 into 64 gram. Is agreeable to you? Okay. Now for the first part. For the first part, what are you going to say? The volume of oxygen consumed. Now can you see here both the numbers, the top number and the bottom number are known. So my first column will be mass of FeS2. And then the second column will be volume of O2 at STP. Mass of this is 4 into 120 gram from the chemical equation. So volume is going to be of SO2. There are 11 molecules. So there are 11 moles. So the volume will be 11 into 22.4 liters. Okay, at STP. And so it will be 60 grams, then X. Understood how to form this? X will be equal to, tell me, 60 into
60 into
11
11
into
into 22.4
22.4 upon
upon
4 into
4 into 22.
ha. So 61s and 62s.
62.
Okay, then 4 goes here, 4 5s and 4 6s, and 2 goes here, 2.8. Now 2.8 into 11 will be 8 here, 0 here and 3 here, correct? So it will be 30.8 liters at STP. And here you will say volume of O2 at STP. Understood how to proceed with this? Now weight of ferric oxide means the second one. For the second one, the first column remains the same. So write this first column, and this is going to change. While you write, I'll just clean this, okay? And they are saying mass of Fe2O3. So from the chemical equation, this is 2 into 160 gram. So 60 gram, then X. So what is X equal to? Numbers across multiply. 60 into 2 into 160 divided by 4 into 120. Okay, 61s and 62s. Always this cancellation you should do first. Okay, then 4 goes here 40 times. So you got 80 gram. So you will say mass of Fe2O3, and this is how you will get your answer 2. Now tell me.
Want the 2 be cancelled?
Yes, ma'am.
E upon 2 also is there, no? Oh my goodness. Oh my
14,
goodness.
ma'am.
Yeah, sorry. Big time mistake I made, Ray. Sorry, huh? Okay. Now we come to the third part. What is the third part? Third part, you will write the first column as it is. Can you write that? And the second column will be mass of SO2. Now you all tell me what to write here.
8 into 64 gram.
And here X.
X
So you will say mass of SO2 equal to, tell me,
equal to
60 into
60 into 8 into 64 upon 4 into 120.
Very good. Cancel this first. Okay, so 4 goes twice and 2 get cancelled. So 64 gram. Okay, so we wrote mass of SO2. Make sure that you write this statement also. Okay, don't just say equal to. You should write X equal to, and then it becomes proper. If you don't write this part, do you know what this means? That whatever you written above, that is equal to this, and the whole thing slashed, you'll get a 0. Understanding? That is why writing the statements are it is so important. Now why fluorine has lower EA than chlorine? You can electron affinity. You can do this. This is a learning type. What is this? Metal M above.
Ma'am, while writing the paper, ma'am, you told us that question 3 is out of the syllabus. Ma'am, the third part. This, no, ma'am, the third part is.
This one, no?
Yes,
Yeah. It is actually 11th and 12th standard work. Yeah. Then metal M is above hydrogen in the activity series, and its oxide has formula M2O. This oxide dissolved in water forms corresponding hydroxide, which is a good conductor of electricity, and they are telling you state the number of electrons in the outermost shell. To begin with, if it is valency M, the compound is
M1.
M2O. So this is 2 minus, so this is 1 plus, correct? So what you
Yes,
will
ma'am.
say, therefore number of valence electrons. No, outermost shell of M. Number of valence, sorry, I just double checked. Valence electrons is going to be 1, correct?
1.
Now B. Name the group. Which group does it belong to? It will be group 1A. Correct or no? Group 1 or 1A.
Yes, ma'am.
Okay. So this was good enough. Then fountain experiment. They are telling you blue fountain. Blue means this is red turning to blue, means it is going to be alkaline. If it is alkaline, then which gas it will be?
Ammonia.
Ammonia. If it was red here, if it was blue here and red here, then it would have been hydrogen chloride gas. What does it demonstrate? High solubility of ammonia gas.
Solubility of ammonia in water.
Correct or no? No. Then and basic nature of ammonia. Red litmus solution is replaced by methyl orange. So remember your parab OP. Okay, CCP and
CCP,
PCP. Now methyl orange means this. This is neutral, this is acidic, this is alkaline.
Alkaline.
So methyl orange will turn orange to yellow. Are you with me? Did you understand how to
Yes,
think?
ma'am.
We can't write each and every answer just now. Okay, we have to move very fast. Which property of sulfuric acid accounts for this thing? Because it has strong affinity for elements of water, that is H and O, correct or no? And it removes the elements in the ratio 2:1 from the chemical combination. Now here also they are telling you electronic configuration 281, 287, 288. Why is the ionization energy of C highest? Where is C highest? What will you say highest? Because it's a noble gas.
Noble
gas. The octet is complete, correct or no? Doesn't need to lose electron. And A is the lowest. Why A? It is group 1A. Now for A, you will have to write a little bit of bhajan. Remember, it will have large atomic size and less atomic number. Okay, large atomic size. That means if the large atomic size is there, it is going to have less pull on the valence electron. So with less energy, those electrons can be removed. Okay, what type of bond will be formed between A and B? This is a metal, this is a non-metal. So it will be ionic bond. Draw electron dot diagram for this. You can do that. A is going to be like this and B is going to be 1, 2, 3, 4, 5, 6 and 7, and this electron will be given here. That will give me A as this. I'll write as 281 will become 2, 8. So it will become a cation, plus B is 287.
7.
So now B is going to become 1, 2, 3, 4, 5, 6, 7 and this 8. So that will become minus sign here and it will become 288. And then that will become your AB. Understanding? So that is the electron dot diagram for 1 mark. 2 reasons why platinum is not used in contact process.
It is expensive.
No, expensive is not this thing. There are 2 reasons. No. So contact process, remember the whole contact process, the big paraphernalia that you see is so that the impurities are not there, correct? So when the impurities are going to poison the catalyst, platinum must be allowing the catalyst to poison it, correct? So what you can say, number 1, it is expensive. Number 2, can be easily poisoned by the impurities. Okay, balanced chemical equations, necessary condition. Basic gas from nitride of divalent metal. Basic gas means ammonia. Nitride, remember I told you to remember
MAC,
or CAM. So Mg, Al and
Mg,
Ca.
Al and Ca.
So divalent metal you can take either Mg or Ca. So if I take Ca3N2, remember I need 6 of warm water. 6 of warm water. Understanding? So this I have told you to consider water as H and OH. So it will become 3CaOH twice. Okay, then 6H and 2N means 2NH3.
NH3 up arrow.
Phosphoric acid from sulfur, no, pyrosulfuric acid from sulfur trioxide. This is easy. SO3 is dissolved in H2SO4 conc. You must mention that, otherwise you will lose your mark. So H2 is
S2O7.
And this is your pyrosulfuric. Oxidation of carbon with nitric acid conc. This is easy. You will get CO2, H2 and NO2. Balance, what is this? For extraction of aluminium. Name the solution used with bauxite as the first step. Conc sodium hydroxide in Bayer's process. Give the suitable reason. What you will say? Bauxite is amphoteric, but the impurities are not amphoteric. So only bauxite dissolves in the concentrated alkali and the impurities can be separated. Okay, can we only discuss this? Give balanced equations in A. Can you do that? What is the reaction? 2H2O plus 2NaOH. What is the temperature? 150
to 200 degrees Celsius.
Gives you 2 NaO2 plus 3H2O.
NaO2 plus 3H2.
Okay, then this is electrolysis of copper sulfate carried out using copper electrodes. Copper electrodes means blue solution will remain blue, it will not fade, correct? Compare the change of mass. Change of mass of cathode. What will say? Cathode mass increases, and with the anode, so what you'll say? Anode mass decreases, correct? Because anode takes part in the reaction. Understanding? But when they say compare the change in mass. Change in mass means, yeah, this increases, this decreases is correct. Write the ionic equations for reaction taking place at both. So for cathode, what will be the ionic reaction? Cu2 plus 2 electrons gives you Cu. And the anode reaction, you will have Cu loses 2 electrons and becomes Cu2 plus, which goes in the solution, and the color of the solution does not fade because for every Cu2 plus ion from the solution that gets deposited at cathode, one Cu2 plus ion from the anode replaces it. Did you understand what I said? Yeah. And so the number of Cu2 plus ions in the solution remains the same and the blue color does not fade. You should know this by heart. It's a learning work. Okay. A and B undergo the reactions, identify the anion. This is practical chemistry. Conc sulfuric acid added to A. Gas is evolved that fumes in moist air and does not decompose further on heating.
Chloride.
With conc sulfuric added to A, evolved that fumes. So if it is HCl that is formed, HCl fumes in moist air and does not decompose on heating, correct? So your something plus sulfuric acid, so this must have Cl in order to give me HCl. Okay, supposing now conc H2SO4 is also used with a nitrate, it gives you nitric acid. But nitric acid further decomposes on heating, no? But HCl doesn't. HNO3 decomposes. With conc sulfuric acid, you can have NaNO3 as well as NaCl reacting with conc H2SO4, correct? If it is NaNO3, I'll get HNO3 as the product. If it is NaCl, I'll get HCl as the product. And HCl will not decompose, but HNO3 will decompose. They say it does not decompose. And plus, this is highly soluble in water, so it is going to be fuming in air because it reacts with the moisture in the air and forms tiny droplets. That's why the fuming happens. Correct or no? Is it coming to your mind? Yes? Okay. Dilute hydrochloric acid to B produces gas which turns moist lead acetate paper black, means it is H2S
H2S.
gas. So B must be having sulfide, no? Because hydrochloric acid will provide that H and sulfide will be provided by this B. Okay, so you have to write sulfide and into bracket S2 minus. Distinguishing test. When it is distinguishing test, I have told you to make the columns. So many of you are not making the columns. So test over here and dilute H2SO4 and dilute HNO3. Now tell me, they have not given you the reagent. Is there anyone who gets confused which reagent I should take?
Yes, ma'am.
Okay. Now you have doubt, let us say. So you have to see what is different, SO4 and NO3, right? So you must remember that with SO4, BaSO4 is going to be insoluble white PPT. So I will take barium in this reagent and I'll take nitrate and I will say add barium nitrate BaNO3 twice solution to each. Understood how to go with this? So Ba will take SO4, it will form BaSO4, this Ba nitrate and this also nitrate. So here what you'll say, if no change, does it make sense to you?
Yes, ma'am.
So here what you'll say, if white PPT of what? Of what? BaSO4 formed, comma, insol, double underline insol and white, insol in dilute HCl. Actually all mineral acids will make it insoluble only. So dilute acid, then SO4 2 minus present. So this is the test for SO4 radical. Therefore I will say that H2SO4 present. Okay, double underline the keywords. If no change, then HNO3 present. Okay, hello. Now in place of this, you could also take PbNO3 twice. Okay, if it is PbNO3 twice, then I'll get PbSO4, which will be chalky white PPT, and here there will be no change. Understanding? Hello? Understanding?
Yes,
Now
ma'am.
sometimes they'll tell use PbNO3 twice. They say use PbNO3 twice and distinguish between dilute H2SO4 and dilute HCl. Then what you have to do, this is going to give me PbSO4 here and PbCl2 here, and both of them are chalky white PPT. So how will I distinguish between PbSO4 and PbCl2? So you have to say add PbNO3 twice and heat. Why do I write this heat? Because PbCl2 will be dissolving in hot water. Correct? So what will I get observation over here? Tell me. If chalky white PPT of PbSO4, which is insoluble even on heating,
Yes, ma'am.
and then SO4 2 minus present, then H2SO4. Understood? Here what will I say? If chalky white PPT which dissolves on heating, okay, then PbCl2 present, therefore dilute HCl. Understanding? Understanding? Okay, so complete these reactions. These ones are very simple. Yeah, all these are very simple. Can we stop here? We continue with question number 7. Choosing the substances given here, you have to prepare copper sulfate. Now anytime you have to prepare this, some children do get confused. Put a slash between the positive and the negative. Now remember, copper is, if you look at activity series PSC, Ma, Zil, then comes hydrogen and chapter. Okay, so Cu is lying below hydrogen. So I cannot say that Cu will take SO4 means dilute sulfuric acid. This I will never be able to do because copper will never displace H of dilute acid. So I will take a copper and I will take sodium carbonate. No, it will not work. But I could take copper carbonate. For copper, I will take copper carbonate, and for sulfate, I will take dilute sulfuric acid. Can you see that? What will I get? Come on, quickly tell me. Cu will take SO4.
CuSO4 plus H2O plus CO2 are
Very good. Now H2CO3, remember carbonic acid is unstable. So always what you write is H2O plus CO2. You're with me? So this is how we will prepare. Iron 2 sulfate. Now iron is above PSC Mazi. Can you see iron is above hydrogen? So I can take Fe and I can take dilute sulfuric acid, and Fe will displace H and it will become FeSO4 plus, correct? Now remember, FeSO4 is light green in color. So they can ask you this question for observation also. And of course, you will say that effervescence of colorless, odorless hydrogen gas. What is the test, confirmatory test for hydrogen? It extinguishes the glowing splinter with a pop sound. Okay, now let us come to give reasons. What is the give reason? First one, carbonic acid gives acid salt, but hydrochloric acid does not. Now carbonic acid is H2CO3. This is your thinking step, and HCl has this formula. This has only one H replaceable in its aqueous solution, but these are two. So how will you mention in your give reason? Carbonic acid, like write quickly so that your fingers get good exercise for writing. Carbonic acid into bracket H2CO3 has two replaceable H atoms, means hydrogen atoms, per molecule in its aqueous solution. Now remember, you cannot just say in one molecule full stop. In the aqueous solution is important to mention. Put comma and say which can be partially. So this is another keyword. They can be partially replaced, underline that, replaced by a metal / NH4 1 plus ion to give an acid salt. Correct? The keyword partially replaced. Then in the next line what you'll say, but hydrochloric acid means HCl has only one hydrogen atom per molecule in underlying aqueous solution. Underline 2 replaceable hydrogen atoms and 1 hydrogen atom which cannot be partially, underline cannot be partially replaced, full stop, hence cannot form what? Acid salt. Okay, so this much will be written there. Electrovalent compounds exist as hard solid. So you have to mention the first thing.
Electrostatic force.
Yeah, but you'll have to add one more word there. Electrovalent compound, they are made of ions, right? Correct or no? So what you'll say, have ions held together. Tell me what is the keyword here? By strong. This word is important. Strong what?
Electrostatic forces.
Electrostatic force of attraction, not forces. Force of attraction. Why do we say forces? Between cation and anion, forces, force, है ना? Yeah. So force of attraction, understanding, resulting in, they held together by strong, resulting in hard solids. Okay, now remember, covalent compounds, they are not hard solids. Reason being, they don't have ions. What do they have? If they're covalent, supposing it is covalent compound. For covalent compounds, what you'll say? No, they have molecules. Covalent compounds have molecules which are held together by not strong but weak. Which force? Van der Waals force. Okay, and therefore they become soft solids, liquids or gases. Understanding? So the keywords, what are the keywords here? Ions held together, strong, electrostatic. Okay, because in covalent the same two words can be changed. Now let us look at your observation. This is your part 3 of your question 7. Excess ammonium hydroxide is added to the substance obtained by mixing silver nitrate and potassium chloride. Now they are saying that this is your question. AgNO3 and KCl has been added, and then whatever you get, to that you are taking NH4OH. Okay, now what will be the products here? I will get AgCl, correct, plus HNO3. Now AgCl, remember, it's a chloride here. What did I tell you about the chloride? Right, in the margin.
It should be KNO3.
Yes, ma'am.
KNO3. Now it is correct, right? Yeah. So if you
Yes,
say chloride, you have to remember HAP. Means what? Hg, Ag, Pb chlorides are insoluble. So what is this? This is a PPT. So the observation will be the precipitate. Now AgCl, what is the description, the full thing? What is the full description for this? Curdy white. Write it down. You have to know this by heart, okay? Curdy white precipitate. Just I'm writing PPT in the exam, write precipitate of AgCl is formed, which is now NH4OH के साथ what will happen to AgCl? Which dissolves, no? So which is soluble in NH4OH solution. Okay, forming clear solution, colorless.
ma'am, would it be excess and NH4OH
No, they
solution?
didn't use the word excess, no, here. Oh, they did. Soluble in, yes. Yeah, excess. Excess NH4OH. I forgot to see this, sorry. Forming colorless solution. Okay, and if they ask you for any reason the reaction, it is 2NH4OH and it will give you a complex salt and plus 2H2O. And what is the compound here? Diamine silver chloride. So NH3 twice Ag, है ना? Diamine silver chloride, which is a soluble salt. Okay, so that is important. And what you have to remember, 2 here, so 2 here. But if it is with copper hydroxide, and when you have, remember, no, this is your NH4OH, excess of NH4OH, what you will get here? Tetramine. So tetramine means NH3 4 times and Cu, and plus NH4 twice SO4. So that will give us what will it give us? SO4 and plus 4H2O. Okay, so you get here 2 NH4OH and here you will get 4H2O. For silver chloride you get 2 here and 2 here. For copper and even zinc tetramine salt, you add a 2 NH4OH and you get 4H2O and the complex salt. Okay, so these are the shortcuts to remember those reactions. Barium chloride is added to magnesium sulfate. So you will write the reaction so it helps us. What will it give me? BaSO4. Now barium sulfate, what did I tell you? It is a white precipitate which is insoluble in all mineral acids, but your book says it is insoluble in dilute HCl. So what will be the observation? This is white PPT of what? BaSO4 is formed, which is insol in dilute HCl. So that is the observation over here. Next one is this, where lots of you had a problem with the calculations, and I'll tell you the reason why it is happening. They are telling you molecular formula, so you will have element, then you'll have the percentage, then you have the atomic weight, then we'll have the broad column which says relative number of atoms, and then you'll have the last one which is simple ratio. If it's hydrocarbon, it will have carbon and hydrogen. If it has 20% hydrogen, 80% of it is carbon. You know that carbon is atomic weight 12, hydrogen is 1. Relative atoms will be 80 upon 12, and here it will be 20 upon 1, which is 20. Now can you see over here, 4 will divide both of these and it will give me 20 upon 3. Now I know that you know your tables well and you get over here 6.67 and here it will be 20 itself. Agreed? Which one is the smallest? This one. So rather than using approximated, can you see if you use these two, you'll get quick calculations. So it will be here 20 upon 3 divided by 20 upon 3, and here it will be 20 divided by 20 upon 3. Won't this be giving you a better calculations? How many of you have wasted a time in using this and saying 20 upon 6.67, and then you have wasted time doing the long division? Did you understand? Look at the pattern. Can you see they are direct multiples? Even if you write this in our calculations, use this. Understood the part? Hello. So our empirical formula is going to be C1 and H3. So our empirical formula weight, in the exam you have to write the full form of this, okay? I am writing it very, very fast, and then you will have molecular weight, no? Molecular formula weight is going to be 2 into vapor density, which means it is 2 into 15, which is 30, which is good, but I'm not using that. So N will be equal to the molecular formula weight upon empirical formula weight. So that will be 2 into 15 upon 15, which is equal to 2. So now I will have the empirical formula. I will have molecular formula is going to be equal to N into empirical formula. So 2 into CH3, which is C2H6. So this is the molecular formula. Understanding? So sometimes they will ask you what is the name of the homologous series to which it belongs. What will be the homologous series? Tell me.
Alkene.
Alkane. They can even ask you what are the characteristic reactions it will undergo.
Substitution.
Substitution. Because if it was alkene, then we would have said addition reaction. Now supposing in place of this, you had got C2H4. What would be the name of this compound?
Alkene.
What would be the structural formula?
C double bond.
Understanding the questions they can ask you, even in our empirical formula, molecular formula, if you get the molecular formula like this, they can ask you to write the structure. Then they can ask you what is the product formed when it reacts with bromine in carbon tetrachloride. So what will be the structure? 1,1 valency will open up and I will get like this. This you have to see in your mind's eye. What is the name of this? 1,2 dibromo ethane. Okay. Now they are telling you lead and tin 50%, 50%. So this is going to be your fuse alloy, correct? And what is the use? Uh,
Break the
no,
circuit.
sorry. Alloy is solder, no? Solder is the alloy, and the use in fuse in electrical circuit, and little bit of physics you can add here as a safety device. We don't have to write that it melts and breaks the circuit. That will be for the physics paper. Okay, so solder underline, fuse underline. Okay, understood. So with that we finish with this paper.